Hello children, so here we will try to understand now behavior of metals and chemical behavior of metals. To understand chemical behavior of metals, we should try to understand the individual difference in the way metals react to a given reagent. Say for example, we should understand how if a metal is exposed or treated or heated with oxygen, how will it react, what are the things it will form, and what will be the rate of reactions, what will be the product, and how fast new things can be formed. What I am trying to tell is that, say for example, all the metals, most of the metals I will tell, will react with oxygen, and suppose metals react with oxygen, then how much of metal oxide will be produced, because when metal react with oxygen, metal oxides are produced. So what will be the rate, how rapid the reaction takes place. To understand all these things, we have to understand the reactivity series of metals. So what is reactivity series of metal? It's a series in which metals are arranged in decreasing order of their reactivity. That means most reactive of the metals at the top, followed by the next and the least reactive at the bottom. So there is a technique to learn this, reactivity series. How we can learn is, I remember a simple name, I call my friend's name is PSC Magnetal. So I am writing over here PSC Magnetal. Okay, so how do we go about this is, P is potassium. So the most and the highest, most reactive of the metals of our use will be potassium. Now children, these are basic things, I am addressing the children. Don't write P for phosphorus, phosphorus is a non-metal, remember that. Then next is S, many children will say, they will get confused, sulfur or sodium. Sulfur is a non-metal, so it will be sodium. Then C4, carbon or calcium. Carbon again is a non-metal, so it will be calcium. Then M4, magnesium. A for aluminium. Z for zinc. I for iron. So don't write I for iodine. Iodine is another non-metal. N for nickel. T for tin, Sn is its symbol, and lead. So that means the most reactive is on the top, followed by the next. That means here only you can comment, if oxygen reacts with potassium, a vigorous reaction will take place, very fast and rapid rate potassium oxide will be produced. Same case is with sodium, but when you go further down, then the difficulty level, that means more conditions have to be supplemented, or more condition like heating has to be provided, etc., more pressure, so that reaction will occur with oxygen of the metals lower down the reactivity series. It's like, the nature of human beings. Some human beings are aggressive, very social, some are loners, like that. So same way in elements, some of the metals are very highly reactive, and some of them are almost inert. Now till here it's very good, well and good. Now from here we have to keep one non-metal, hydrogen, and then we have to continue with lesser reactive. That means I don't have a board space down, so I will you have to write below in your copy that now much more less reactive metals now are coming. So the trick for remembering this is your friend's name, as I said, PSC Magnetal. Magenta. This if you can memorize, then you have understood PSC. Magenta is your friend's name, alright. So, this is the list over here, PSC magenta. Now, then after hydrogen, below this, but I do not have board space, so I am writing over here, Chief Minister, smart, good politician. Chief Minister, smart, good politician. So, C4, now these are lesser reactive, copper, symbol is Cu, M for mercury, Hg, S for silver, Ag, G for gold, Au, P for platinum, PT. So, students, if you have to give your exams well, you have to know these symbols and perfectly knowing about few metals and their symbols and non-metal, and you do not have to confuse between a metal and a non-metal. You do not have to say carbon is a metal or sulfur, you start thinking. You have to write in the beginning of your chemistry metal non-metal class, you should very nicely memorize which are metals, and you also know why why they are metals. In my previous video you have to have a look. Now, next thing is that knowing this, where do we land up? What are the benefits knowing the reactivity series? Number one is, when the elements were made, the least reactive elements will be found inside the earth crust in their free state or native state. That means, if you see platinum or gold as minerals on inside the earth crust, you will get gold. It is not in a combined form, you do not get gold compounds, you directly get gold as mineral, alright. And when you further go, silver, gold, platinum, even mercury, and might be some of the places copper you can get in free state or native state. Copper you can have a balance here, that it is also found in its compound form. Now, what happens to these which are very highly reactive elements? So, once they are formed in nature, they will react with oxygen and can be found in oxide form, or they can react with chlorine, or they can react with oxygen, chlorine, etc., and they can be found in their combined state in form of their compounds, alright. For example, there is a very big compound where potassium can be seen, that is potass Lm. I think so the formula is K2SO4 into Al2SO4 whole thrice into 24H2O, which is also known as potass Lm. So, potassium is present here also. Cryolite is Na3Alf6. Now, here you see sodium is here or aluminum is here. Aluminum is also present in aluminum oxide with water of crystallization, which is also known as bauxite. So, these, if you do not find aluminum inside earth crust in free state, you do not find. And therefore, first is how do metal occurs, you can comment after knowing and learning about reactivity series. You can say that the more reactive metals will be found in their compound form like these, and the less reactive metals will be found in their free state or native state. Gold, etc., gold, silver will be found in native state or free state, whereas aluminum, etc., sodium, you can see they will be found in their combined state in their compound form. Now, here when we are working on metallurgical processes, then we have to understand all substance which are found on earth's crust are called minerals. Minerals can be compound of metals, non-metals, and mineral can be directly a metal or a non-metal. All the substances which are found in or on earth's crust, they are called minerals. But what happens, have a look. Suppose you have to extract aluminum. Aluminum is present here also, and aluminum is present in potash Lm also. So, where you will get where from you can get and extract aluminum. So, you can open an aluminum foil industry, that is pure aluminum. So, what has to be done? So, we have to understand now two terms. One is minerals. What are minerals? Minerals are as I told you, substances which are found in or on earth's crust. They can be metal compound, they can be non-metal compound, they can be a metal or they can be a non-metal. But from mineral it is not necessary that we take out or extract a particular metal, especially when they are in combined state. Say for example, if I have to extract aluminum, I should extract aluminum from bauxite. It will be much easier than I have to extract aluminum from potash alum. So a term now comes, a comparative term, mineral and ore. Mineral and ore. So what is there? Minerals are, as I said, substances. Minerals are substances which are found in or on earth's crust. They can be metal compound, they can be non-metal compound, or they can be purely the non-metals or the metals. But ore will be those minerals from which metals can be extracted easily, conveniently, cheaply, profitably. Many words you can use. Or ores are those minerals actually from which we extract metals. Alright. So all ores are minerals, but all minerals are not ores. This you have to understand, and you have to know the formulas of a lot of ores. Like so to know the ores there are two ways to memorize ores. One is element wise, like you can memorize ores of iron, like it is hematite, it is siderite, it is limonite, like that, or an aluminum bauxite, it can be cryolite, and so on. Or copper, you can have copper pyrite or cuprite. So their formula has to be understood. A list of those formulas I will be pasting it or presenting it in the last of this video. So you have to understand, once more I said that reactivity series is important, and also when you are commenting about how a particular metal reacts, say for example how metal will react with water. Sodium and potassium will react with water and will surely form oxides and may be releasing hydrogen, but the reaction will be very vigorous even in coldest of water. Even with ice, sodium can react, and that is why sodium is kept under kerosene, so that it does not react with water or oxygen if it is exposed to air or it is exposed to water. So it is very highly reactive, so it is kept inside kerosene. And also then when you go further with oxygen, these are reacting. Aluminum will react initially when it is newly formed to form aluminum oxide. I am talking about oxygen now. How aluminum will react with oxygen? Aluminum will react, these will react very fast, as you know. Potassium will react with oxygen to form potassium oxide, sodium will form sodium oxide, calcium will form calcium oxide. When you are coming down, aluminum, freshly prepared aluminum also reacts with oxygen, but it forms a thin film of aluminum oxide, and then it prevents further reaction of aluminum with oxygen, and it forms a passive layer on the aluminum surface. So now aluminum will not react. So this is a freshly prepared aluminum. Normally aluminum is a bluish white metal, but when you look at after some time, might be I cannot let you see the frame of the board, but in your window frame you see it becomes grayish white because an aluminum oxide, you can say lamination, a very thin film of aluminum oxide is formed on aluminum surfaces. And when you go further to iron, then red hot iron will react with oxygen. Otherwise, with reaction with oxygen in presence of moisture is a slow process. So knowing reactivity series will benefit you to understand chemical nature of element and the way they react with a particular reagent. Thank you.